All right. Well, I'm going to need just about the entire time allotment, so I'm going to get started. Let's cycle back over to chat for the. Oh, that's because I was looking at the people list for the entire event, not the session. These tabs at the top of the chat are a little too vague. But yeah, so I'm going to go ahead and get started. Make sure. Yeah, hello, Sydney. Yeah, bring it on, Casey. Um, oh, Matt, new job's good. Was a bit stressful for a little bit, but getting my feet underneath me. So I'm here today to talk about Vecto. Um, as I have been wont to do in several of my previous presentations around the LabVIEW community, doing 100% LabVIEW open source. And this is a communications library for larger distributed applications. As Darren already called out, also the presentation where, yes, I wrote another networking library. Um, this is what I am have wanted to create for the last couple of jobs I've been at, where we've needed more robust communications and more performant communications. So it's what I'm using. Um, I didn't put the XKCD comic in here about uh, yet another new standard. I'm not trying to convince anybody to use it, but if this looks interesting to anybody, here it is. So if I focus on the correct window, so me, I'm almost at the 15-year mark of doing LabVIEW development. I currently work at Vast Space in Mojave, working on test software for everything from structural testing for space station hulls to thruster hot fires to launcher's E2 rocket engine test stand. And if anybody has been following Vast, we're getting a lot of milestones done, and there's a lot of testing to come. So on that note, we've got a position open. It will be on site. You must be willing to live near Mojave, California, and be a U.S. persons, since we are a space company and work with NASA and stuff a whole bunch. Um, and the latest hobby I've started, I tend to start most of my presentations off with, "Hi, my name is Derrick, and I have a hobby problem." My newest one is turning my garage into an arcade. There aren't any arcades in town, so I am being the change I want to see in the world. So why Vecto? And I'm going to refer to point number one a couple of times throughout this presentation. I figured I came up with the only unarguable reason is that I'm picky. And two, I can, so why not? Um, I like writing code that better fits what I'm trying to do. Um, I have spent a bunch of time trying to make things that weren't written for my use case usable for my use case. And With all of the tools in my tool belt, I tend to be happier if I make exactly what I'm looking for. So why not some of those other examples? There's lots of communication libraries around that people are using. Um, One of the presentations earlier was talking about gRPC, NI's gRPC toolkit. ZeroMQ, ZeroMQ has a good LabVIEW wrapper. MQTT is pretty accessible. But there's just always something that I get to be picky about with them. Some of them lack desired functionality, like ZeroMQ doesn't let you know if you're connected or disconnected. You just have to infer it on whether or not you're getting data, which is great when your only focus is throughput of data. But when you want your console to immediately display errors because you got disconnected from the network, um, you don't want to wait 5 seconds to go, oh, wow, my data is stale. I should probably do something about that. Um, a lot of them have a centralized message broker. Not that I don't, but it's not the only part of this implementation. And I've seen a couple of jobs in the past where a central server becomes a bottleneck. A lot of them, you spend just as much time configuring them to get mostly what you want than you would have doing something simpler and more catered to what you were looking for. And just some libraries that are available out there and have been wrapped in LabVIEW just don't fit LabVIEW very well. And I didn't just write one. As I mentioned, a centralized message router is only part of this. So this is three protocols in a trench coat. So Vecto is Latin for carry or convey. Casey asked me how I keep coming up with names so quickly for all of my libraries, and Google Translate gets a fair bit of traffic from me. So it uses UDP multicast for the periodically updated telemetry. It is UDP, it is lossy. The idea is that if a packet gets dropped or shows up out of order, there is a packet coming not long after it. So who cares? Let's not delay every other message because a piece of high bandwidth data didn't make it through. It is not a new standard. Standard's a really strong word. Um, so yeah, it does use TCP for ordered commands and request to reply messaging patterns. And then it also embeds an HTTP server for larger transfers, like uploading data files, downloading data files, updating configuration files, making status requests, things like that. So, an agenda slide feels like it needs to be part of every presentation. But I'm gonna start. Well, I've already talked about what Vecto is, kind of very vaguely. I'm gonna talk about what Vecto is not. What my goals were for designing this library, um, how it's organized, and this does use Protobuf as its serialization format. So we'll talk about Protobufs, get into a bunch of demos, and then probably not have any time left for me to talk about the framework I've written that closely wraps all of this up. At the very end will be links to all the open source libraries. I can post those in chat as well. So the idea is that Vecto is only opinionated about the things that it needs to be. It doesn't provide a module pattern. It's not an application framework. It's not a module framework. It doesn't even specify a configuration file format. It just has a handful of classes that you need to populate the configuration information with, and that gets passed into the framework. So you're responsible for writing some boilerplate and some shim layers. But the idea is that you can do that in whatever framework or not you want. Definitely recommend using a framework. Um, and if you don't want to write any of that information in any of that shim layer, maybe take a look at Volatus, which I'll very briefly show off. Um, Internal to Vecto, it uses all base level mechanisms for its internal asynchronous processes. It doesn't use DQMH or Actor Framework or anything. It just directly launches asynchronous VIs when it needs something running in parallel. And just as a bit of trivia, these days I tend to prefer events for most of my component messaging. So the goals for this were to be 100% LabVIEW, at least for this initial LabVIEW implementation. Anything that the code generation does, any of the communication layer, I want you to be able to Splunk as far down as you want to go until you land at all LabVIEW native primitives. A lot of like NIGRPC calls out to shared libraries. Um, DDS, 0MQ are all wrappers around DLL code. So I wanted this to be as accessible as possible, not just for me, but a lot of the people that will be on. A lot of the people, there's like two other people that will be using this at my current job. Um, but yeah, just be able to get down to the lowest layer and not have to change contexts for debugging any of that. I do want this to be scalable for large distributed systems, is what it is being intended for, like a large rocket engine test stand where there might be a dozen data acquisition and control systems, all handling some of the data and some centralized automation and logging servers, a couple of operator console GUIs. But when we have a use case where we just need a single application and a compact DAC chassis, I don't want to need to set up an embedded target and a communication server and a handful of different things that all need time configuring and testing and all of that. So a lot of the same data handling mechanisms and module and not module patterns. Uh, Volatus keeps leaking into my brain. So a lot of the data handling mechanisms are usable in single process systems. Um, that being said, I do want other people to be able to write tooling that can interact with this and do that in Python or .NET or Go or whatever else. Um, and that's what drove initially looking at something like ZeroMQ, but landing on something custom, but uses Protobuf as a serialization format. As we'll look at, Protobuf provides tooling to generate the serialization code in a handful of languages, so it's much easier to interop instead of just using like LabVIEW flattened strings or stuff like that. And I want to provide debug tooling that requires next to no configuration. We'll be taking a look at that in the demo. And again, remain as unopinionated as feasible. So Vecto isn't an application framework, but it is a little bit frameworky. It does expect you to organize the concept at a conceptual level, notionally, your test system into a couple of layers, uh, as well as operate on group based data. Um, so these are the hierarchy layers that Vecto is set up to handle. If you're doing a single application or a small system, you might just set your system cluster and node name to the same value or end your task and call it a day to be able to use Vecto. We'll actually see that in the demos I'm going to show off. But the idea is for a larger distributed system, you might have different applications that aren't directly communicating to each other. You don't want them knowing about each other with some of the auto discovery services that are implemented in this. So you can split them up into different clusters. 99% of the time, there's going to be a single cluster. And if everything is performant as I hope it remains as I continue to build this out, there wouldn't really be a need to split things up. Node is just another name for an application. Sticking around with some verbiage that vocabulary that exists in my current job. Tasks. Almost all applications are going to have things split up into some kind of modular code base. And then Vecto just calls that a task. It does have some built in debug reporting capabilities for reporting the status of tasks if you're supplying that information to Vecto. And then, of course, groups and channels. So groups are just the collection of channels, and all channels in that group have the same data type. I already chatted about this. It doesn't specify any config format. You're expected to programmatically build the configuration object from whatever your config format is. Um, and then the other idea is that that configuration does get shared among all of your distributed applications. The idea is we'll see in some of the demos for publishing and subscribing to the data that the different applications need to understand the group configuration being published by the other applications. So the easiest way is just share the config. Have one big system config. So protobufs. If anybody wants to let me know in chat if they're already using gRPC or protobufs, I'm just curious how much this is starting to get used in the LabVIEW world. I know the microservice architecture presentation was using gRPC and protobufs, but curious how much that's made it into the LabVIEW world. So this is Google's serialization format. You can go to protobuf.dev and get a lot of information about it. And there's a handful of languages that their provided tooling works for. Of course, that doesn't work very nicely with LabVIEW CLI tooling, bridging that gap. So I just have tooling that runs directly in LabVIEW. The general workflow is you write a proto file that is going to have specifications for enumerations and messages. It takes that proto file and generates code in whatever language you specified from those definitions. In Vecto, all UDP and TCP payloads are serialized using the protobuf serialization. That's not completely true. At least the wrapper header portion of the payloads definitely are, but it just wraps around a byte array. So theoretically, you could shove whatever you wanted in there, and it would make sure it arrives on the other side. And again, I'm picky, I'm very opinionated, so I have my own proto compiler tooling. Um, to generate actual LabVIEW code again, so that when I'm debugging, that's accessible, and there's just more examples of scripting tooling out there in the world. So I've got my package. It's a little out of date on VIPM. I was having trouble for a while getting VIPM packages to build. So I've just been working from source code repositories, uh, and we'll see what packaging looks like in the future. But so in the upper right is an example of a very simple proto message definition. This would be an example of a message that would get sent from an operator console to all of the applications to tell them to start logging. So they all get the same log name and the timestamp to mark their files with. And then in the bottom, we can see the code that it generated. Well, at least the files that it generated. The main parts are the data cluster. That is what is going to match the message specification in the proto file, and then there's a handful of flattening and unflattening VIs, depending on if you have an array of data or just a single element. There is also a message class that does enable doing some level of abstraction on the messaging. It can be completely ignored if you don't need that. And those class VIs are just wrapping the non-class VIs. So they're you could delete it. It's going to get regenerated again if you make an update and regenerate the message. But that can be ignored if you don't need it. So let's take a look at generating protobuf message and the tooling that I have. So I'm going to use an existing message. We're going to start from that start log message we were just looking at. I'm going to regenerate the code just as an initial introduction to the tooling. We're going to use that generated code to serialize a message. I'm then going to modify the proto, add an additional field so I can say who the log command was sent by. Generally, in a operator console, somebody would be logged in, so we would know who performed that command. We'll use the tooling again to regenerate that code, and then show that we can still deserialize the previous data. The protobuf.dev website has a whole bunch of guidance on how to update your proto files to keep them backwards compatible and make sure that you can't invalidate previously saved data, which could be really great for debug tooling. Maybe you use the protobuf serialization to generate your binary log files. And then over time, you add more fields to it, but you can come back to it and still decode the older log files just with empty values for the unspecified data without having to maintain older versions of the application. So let's swap over to LabVIEW. Normally, this would be in the tools menu if I was installing this from a package, but for now, I'm just going to run the file directly. I'll get to that, Casey. Um, so I'm just gonna browse to that proto file. So start log. And then I'm going to pick the folder that it puts the generated code in. For every enumeration or message that it creates, it does create a library, and libraries go in their own folders. So it will make the start log folder for me. It already exists, so it's just going to replace what's in there. Um, but a protofile can define multiple messages, and messages can be nested in other messages and contain enumeration definitions. So each one of those would get their own file. So we're just picking this top level messages folder, even though this is just creating one. So that finished pretty quickly. Uh, since y'all know this already exists, it doesn't look like it did that much. I'm going to close this and then open the project to write a guy that uses it. I'm going to start a new Scratch VI. This is going to be demo 2. So I've got the start log message library here. I'm going to take my data cluster, put that in there. I usually standardize on ISO 8601 for all of my timestamp formats. So I'm just going to come up with a value there. Go ahead and flatten that. And this is the like the proto tooling that I have doesn't do icon customization. So they are all identical right now. If this looks interesting enough to people that does bother, would love some additional support with it. But we'll go ahead and run this, and here is the byte array that it generates as that payload. I'm going to copy that to a constant and we'll unflatten it and just show that we can get that data back out. And there it is. So I'm going to save this as is with that byte array constant. I'm going to close this because we're going to be modifying a message that already exists in this project. But go back into the tools when it prompts me for the file, pop it open in code, add a third string, and we'll regenerate from that. Go back into the messages folder and close all of that and go back into the project with the demo VI. So we can see the third field is in there now. Um, and in this, it'd be really nice if clusters could like maintain their auto sizing when they update. But let's say that I was logged into a console and sent this start log command. So now it's a bigger message. And we could see that the previous serialized data was still able to be deserialized. Of course, started by didn't exist in the previous data. So it is empty. If you wanted to manage that in your application, you could fill that in with a default value or generate an error or whatever you needed to do if that string was empty after deserialization. And that's the last we're going to look at Volatus for now. So we're going to hop right into another demo and we'll look at the group data mechanisms. So groups in Vecto are by reference and they're managed by a centralized channel service. So this does mean that you can branch their wires and use them in multiple loops in a single process application or share them across multiple modules. Or you can just retrieve them from the channel service a handful of times and they're not actually duplicating the data. You just potentially if you're trying to access it a bunch in a bunch of different places, you'd have some contention on that reference. The idea is generally you're going to have one application writing it and another application reading it over the network, and so you wouldn't be doing a lot of parallel access in a single application. I already mentioned. I think I mentioned. I forget with all the run throughs I did, including the hour before this. There's double and string values are implemented. You can use strings as a catch-all for heterogeneous data. The string group implementation does have a handful of helper VIs for stringifying into readable form, booleans and numbers, timestamps, things like that. But we're just going to start with a single process example, writing in one loop and reading in another loop. And Matt Jacobson, you clearly have not seen many of my libraries. So in the Vecto Scratch, in the walkthrough folder, I've got this single group. I'm going to run this as I slide the sliders on the left. The numbers are updating on the right, and that could just be getting done in a single loop. Uh, but starting over here on the left, this is the channel service I mentioned. Again, this is expecting to be in a distributed application where different components have unique names. For this single process demo, I'm just setting the name demo uh, for all three of the system cluster and node names. Same thing for the group. So as mentioned, there's configuration classes. This is an example of one for a group where you're populating this configuration class that gets then passed into part of Vecto for it to create whatever that configuration is specifying. So I'm just creating 5 values named val1 through val5, um, starting a default array values of 0. So we're using the channel service to create that. The channel service does things like check to make sure that the names are all unique, the channel names are unique. Um, and then, assuming that all passes, it creates it in its asynchronous process. So you can shut down the call and code, and that group will still exist as long as the channel service is still running. We're going to initialize that default set of zeros. And then from there, we start writing to it in this upper loop and reading from it in this bottom loop. So basically, just a current value table. So what is it going to take to get that group going out over the network? There's two new components we're going to need to use. One is the sequence count service. In this framework, all the UDP messages, TCP messages, and HTTP responses do embed a sequence count in them. For UDP, since UDP is lossy, that can make it really easy to detect when packets arrive out of order and ignore old data. And for other messages, you can just correlate what order messages were sent in. So if there's been a configuration change, you can ignore any messages or data updates from before that configuration change message went out, as an example. And then there's the remote data service, which is what is responsible for publishing and subscribing to group data on the network. So we're going to create the group, same exact as before, register it with the remote data service. And then anytime we're done making updates to the values in the group and we want that published, we just call the publish VI on remote data service with that group. Uh, I'm not going to bother running this because this isn't going to do anything yet. But we can see here on the left side, this bottom corner is just about identical. The two of the new things is we have the sequence count service and then the remote data service. Uh, this is showing the individual mechanisms themselves. We'll see when we get to the last demo that there is a class that manages a lot of this stuff that has to get done over and over again for you. Um, I'm just demonstrating the underlying mechanisms with this. Um, you would need to be aware of all of this if you were going to integrate it into your own application framework. Creating a remote data service, and then we're creating the group the same way we did in the last example. Then we're taking that created group, we're registering it with the remote data service, and getting the remote data service running. Magic delay fairy because the asynchronous network stuff in the background takes a little bit of time to get started, so we're just giving that a chance. After that, update the values in the group, just like we were in the single process example, except instead of reading it out in a second loop underneath, we're telling the remote data service to publish the values in that group. And then looking at reading that published data, it's going to look nearly identical. The receiving side still needs a group to put that data into and understand the configuration. So we're still going to create a group with the channel service um, so that the subscription handling can put the data into that group. Um, Instead of subscribing to a specific group, we subscribe to that UDP multicast endpoint. The application will then start receiving because we're going to open one UDP connection to that endpoint. Um, Multiple groups can get published to a single endpoint. It's going to check to see on any group data that comes in if that group exists locally. If it does, it'll update it. If it doesn't, it just ignores it. So if you need to split up what group data goes to which applications, you can use different endpoints. Um, and then yeah, if it's not a high enough impact, you can just let the systems ignore it if they don't know about that group. And then we're going to read from that group exactly the same as in a single process. So I'll reopen the publishing example. Then we'll look at the subscription side, and these two look almost identical. They started out as a copy paste of each other. Um, the other new thing, now that we're doing network access with the group, is we do have to configure on the group what the publishing endpoint is for it. And we're just going to do that same thing on the receiving side. The difference is that instead of registering the group with the remote data service, we're going to tell the remote data service to subscribe to that endpoint. And then we could just start reading data from the group. So I can run this. We can see the timestamp is not a number. We haven't received any data yet. The loop is iterating. And then when I start the sender, we start getting timestamps and data across. And it's pretty snappy, which isn't a surprise for only 5 values and running on the same system. And just anybody, in case anybody's curious, the warning 914, um, it's got event reporting built into it for like debug logging, and I'm not specifying an implementation for that, so it's warning me that it wasn't specified. So that's all of the group-based data publishing and interaction. Um, Anybody have any questions on that so far? Um, I'll say that that came about using UDP multicast because we did have a single TCP stream per connected client implementation that I worked at a job I worked at in the past, and on larger test systems, that was starting to hit its limits. So the UDP multicast was something we had talked about doing at that job and never got around to doing. So I stole that idea from like game programming and some in space vehicle communication specifications. Oh yeah, in case you may. The the many different spacing, no spacing, happened based on when parts of this were written. Parts of this were written, um, at least in Vecto, parts of it were written when it was intending to be uh, integrated into a different framework that didn't use spaces in their names. Uh, Protobuf itself uses capitalized camel casing for message names, but the proto files and some other stuff use snake casing. So yeah, there's kind of stuff all over the place depending on. I was just matching the specific component to whatever the documentation. Yeah. If you have any questions, just look at what where the source for the interaction came from. Okay, so TCP messaging. So the UDP handles all of the stuff that we can allow to be lossy because it's going to continually update. But what about things like commands that we're going to send once and need to arrive? A bunch of communication frameworks like MQTT can do transport over UDP, but then they implement stuff on top of that to do the quality of service guarantees. Um, so instead of doing that, I just did TCP. The idea is that messages aren't sent as frequently as telemetry is. So it's not a huge, shouldn't be a huge burden on any system, and especially for any kind of message routing. So just stuck with TCP, stuck with the thing that made it simple to implement that. Messaging is communication intended for specific targets. Um, Vecto does have implementation for doing the node target message routing, and it doesn't have to be a separate application. We'll look at in the examples. There is a client mode and a server mode. It is the same class, and just depending on which of those two initialization VIs you call, it'll behave either as a client or a server. The rest of the interaction is identical. So again, for smaller applications, maybe you just have a compact Rio running an embedded application and a GUI application. Having yet a third application that needs to be your messaging server, um, just you don't need that. Just make your Rio your messaging server, and your GUI connects to it, and call it a day. So there are two levels of message addressing. There's the node, so which application is it going to be delivered to, and that can include delivering to a group of nodes via target groups, which and all of that routing is implemented for you. And then there's specific task or message type dispatching that would happen in the application. And since this doesn't specify a framework to use, the messaging is dependent on what framework you're using. So it just gives you the names to implement your own dispatching. So request reply is implemented in this as well. Requests under the hood are not a special message, but they are. You send them expecting the remote side, the recipient, to reply and send a reply back. Replies are a specific mechanism, so it can get sent back to the VI that is waiting. Um, this is really great if you've got relatively short exchanges where your calling code can't really do anything else until that response comes in. So that's like an application first starting up needs to know what state a node is in or what state a specific component in a node is in. It can send that request, wait for that reply, finish initializing itself, and start running. If you've got longer exchanges or your calling code does need to do other things in a timely manner, like maybe it's in the loop where you're doing DACMX, reads from DACMX, and you need to make sure that buffer overflow and you don't get the software can't keep up with the hardware error. Just send a regular message, have the recipient send back a regular message, and you just fit that into your normal message handling behavior. So let's look at a demo of that. We're going to look at two new classes again. There's TCP messaging and TCP messaging API. TCP messaging is a bit of a bigger class in its class private data, whereas the API class just has two queue references in it. So it's a lot cheaper to send that all over an application. Um, but you do need to do all of your initialization and registration with the TCP messaging class. Um, I've already mentioned that initialize as a client or server, but all the rest of the functionality is the same. And this does specify an interface, a TCP message handler interface that you provide a child implementation of. Um, and that would get called anytime Vecto receives a TCP message. It uses that dynamic dispatch on that implementation for you to decide how to dispatch that message in your application. In the demos we're going to be looking at, I'm not going to do any dispatching. The demo is written assuming a single message gets sent. So this again, this isn't the framework layer. For that, I have Volatus. Um, and there's also an interface for connection handling. So you can have event driven behavior, event style driven behavior when you connect or disconnect from the server. Most of the time in an application, there's only going to be a single message handler. And then that would use whatever messaging mechanism your application uses to send it to whatever module handles all of your message type registrations and understands the IDs of your different modules, and then it would then send it in whatever your application messaging implementation is. Oh, demo. So on the top, we've got a client. On the bottom, we've got a server. Uh, Sequence count service has returned again. And that is, again, all of the communication that happens with Vecto does embed a sequence count number. Uh, The client handshakes with the server when it connects and gives it its identifying information, so it knows which node it is and can route that the correct TCP connection. So configure all of that naming. There's other fields in here for app version and config version. Again, that's transparent or opaque. Opaque is it's opaque to Vecto. Vecto lets you specify that and just send that along. um, the framework I've built does have built-in mechanisms for checking versions for configurations and applications and letting people know when things are out of date or not in sync. So configure all that with the client. The server is just node ID one, and of course the client and the server are using the same IP address and port to establish the connection. The server is listening on this port, and the client is establishing the connection on it. The server is going to be sending the request. You can see down here in the right, and the client's going to be handling that. So for this demo, this is just a really simple message handler. There is in the TCP payload field, there is a type field, which is a string. Normally, you would do some kind of case structure or deciding where to route it based on that type string or the task ID string if that's being used. But for this demo, I'm not worrying about dispatching. The main two things I want to show is this request VI and the reply VI. So we can see here, this is a really simple example. We're taking two numbers, multiplying them together, packaging that back up, and sending it back to the caller. So um, both of them, once they're configured, start their instance running. Uh, Magic delay fairy, let the connection happen without using the connection handling mechanisms. And again, there's the API class that provides all of the actual messaging. The TCP message class itself does not do any of the messaging. So when you want to do messaging, you get the API instance, and this is really cheap to send around your application. Uh, and that's what you can do messaging and request replies, acts, things like that. So we're gonna make this request. I'm using a some code I built from a proto message definition that just takes two numbers, serializing that, sending that in the request. Uh, with this, we've got the target node we're gonna send it to. So I had configured. Oh, I'm just a little bit out of view. So I had configured the client node as node two. So we're just using that same node ID. Um, Addressing by task is optional. Specifying a message type is required. This demo is not using the type, but most messages would be getting specified by type. And then just whatever your byte array for the data is. Uh, Again, the I'm using Protobuf for all of the messages, but it is just a byte array. You could, read a file into memory and send it as a byte array, and as long as the recipient knew that that's what it was, um, that would work okay. That's kind of like how MQTT and some other messaging libraries work. So, and then we've got a timeout. By default, it's 5 seconds. I know it's going to run really quick, so I give it a timeout of 100 milliseconds. We're going to get that payload data back in the reply and deserialize it and get our value back. So if I run that, it magic delay fairy, and we get the expected 42 back. So the next messaging demo, talk about target groups. Again, this is the mechanism for sending a single message that arrives at multiple nodes. The group ID is the same field in the message as the node ID, so the numbers can't collide. But this is a great way for having a whole bunch of applications connected to the network that all do their own local logging. You're going to send out a single start log message in the application. It would, they would all be the modules that do the logging would register to receive that message. And so you can have a way to broadcast a message to multiple nodes and multiple tasks modules within that application. Oh, I didn't want to stop that. I'm going to alt tab. So this is just the new VI in this example from the previous ones. This is set target groups. So this is just saying for a node, what are the groups it belongs to? So there's three um, air quotes nodes in this demo. There's a client up top, a client in the middle, and the server at the bottom, respectively, with node IDs one, two, and three. And one, two, and three are each of the rows in this. So I'm saying node one is a member of groups four, five, and seven. Node two is a member of four, five, and six. And node three is four, six, and seven. So they're five, six, and seven leaves one of them out. Four goes to all of them. And then you can still directly address to a single node. Um, but I'm just doing a little bit of massaging here to get it into the format that this VI expects for what the node ID is and what groups it belongs to. And then anytime we send a message, we're going to send it to the number in this box. So if I say address this to group four, to target four, we're going to see that the one shows up in all three components. If I send to seven, The 2 is only going to show up in 1 and 3. If I send a message from 3 directly to 1, only 1 is what updates. So this is the mechanism to send out to multiple recipients. Uh, Generally, in the framework in Volatus, what I've done is there's always a name available for the components. Come on, block diagram. There's always these names that are available for the nodes. Uh, So there could be a lookup mechanism to get from the name to the number when you're sending. So you don't have arbitrary numbers littered throughout your code. Again, demo showing the base level mechanism. And then bring it all together. So I mentioned there is a Vecto class that kind of simplifies a bunch of the initialization and the managing of the separate components. Things like sequence count service are going to be needed anytime you're doing enabling any of the networking features. So you shouldn't have to create that yourself. And when you use the Vecto class, you don't. You're going to feed it a node configuration object, and based on what is configured in that configuration object, the Vecto class will enable and initialize the various components that you can then get the channel service from it, get the remote data service from it, and do the group creation and publishing and subscription, things like that. Um, it also runs a bunch of stuff that I've only mentioned and haven't demonstrated, like the auto discovery service, so that the applications can be aware of each other without needing to know what their IP address and ports they're using for their various services. So it disconnects a little bit from some, if network IP addresses change, you can still get their IP address and node IDs and things like that from the discovery service. I ended the slideshow again. Let's go to the demo slide. So we're going to be looking at this a little bit of a behemoth of an example. Again, generally, the idea is you would have a JSON file or SQLite database, whatever your configuration format is of choice. Write some code to generate these objects from that config storage. So most of this would turn into application framework reusable code. But we're going to be setting up an application that does a handful of things and does enable all the features in Vecto. And then we're going to show off the telemetry debugging tool. That the only things it's going to need to know is the system name, the cluster name, and the discovery multicast endpoint. And then it'll use the auto discovery mechanisms to be able to get the names of the channels and start receiving the telemetry data from that. So this is going to be as an executable. I've already built that. We don't want to wait for that. And in this INI file, I did set the allow multiple instances to true, so I can run this a couple of times. And this is to prove that it actually does run as an executable. Um, so the way this works is I have to hit start for it to actually start, and that's because I'm running multiple copies of the same code. So we need to change the IDs, the names, and the HTTP port. So now when I start, well, before I even start the second one, we can see the first one found itself. That's a huge achievement. It knows itself. It knows it exists. But in this bottom discovery table, when I start the second one, we're going to see that the first one was able to see the second one starting to advertise itself, and then in the second application, it was able to see the first application advertising itself. And 3 is a good round number, so we're going to go with a third one. And then we'll see that third one shows up in the other applications. Now, generally, application to application isn't going to be using the auto discovery as much, but it's really great for debug tooling. So I've got one tool so far, and that's this telemetry debug application. It does not have very much going on. It does not. do very much. It does initialize the same underlying components from the Vecto library, but it's not meant to be an application that advertises itself and all of that. So it is using the components more directly. But as long as I run this and put in the expected names, which one was I using? 50. And hit start, it will start detecting the other applications and then start getting their data. There is a bug in the string group for some reason with the timestamps that I've got to look into. But we can see that it is getting updated timestamps for the numeric data. If I scroll down to the third one and start get that in view and start moving these sliders around, we can see that it's getting that published data. I can change the strings and we can see those updating in the right. The strings are great for publishing module state and like configuration versions and other. And the session disconnected and appears to be back. Cool. If anybody can't hear me, let me know. Um, the strings are sorted by name of the channel. So 1, 2, 3, 4 sorts into this order. So that's why they're out of order over here. Um, but this is just an easy way to confirm that data is making it out, and you can kind of just poke at all of the data in its organized hierarchy for your large distributed applications. And I am going to get an error here because there is a component that isn't behaving properly, and I'm other than calling it out, I'm going to ignore it. So that's everything I hope to get through. Um, there's a whole bunch of links for GitHub, basically just illuminated dash G at GitHub. There's Vecto, the proto compiling tool, the under the hood a lot, especially for the request reply mechanism. I use promises a fair bit. Um, and then the HTTP server is the one I wrote. Um, and I post videos periodically about new projects I'm working on to my YouTube channel. That's at Illuminated G8850. And then some upcoming projects that I will probably be posting a bunch of videos. Well, I actually already have. I'll be posting more videos about is Volatus, which is the application framework that I am building around Vecto, which does use my configuration library and is very opinionated about a whole bunch of things. It's QMH pattern, but it does steal a lot of the asynchronous infrastructure that Active Framework uses, but is more approachable to people that whose eyes glaze over when you try describing dynamic dispatch to them. Also, just don't get an explosion of classes for each interaction. And then GPack is another project I'm working on. I One of the things I've been working on is using more Git submodule workflows, but for doing automated testing of things like that. Is a submodule for LabVIEW with submodules. Everything needs to be a peer folder of everything else for all the relative links to stay valid, even through nested dependencies. Basically you can't nest and have recursive submodules because all the relative links will break. So you just need them all next to each other, which means they don't know about each other. And GPack is that glue tooling for getting that across. The couple of people that I have told about open sourcing have said, okay, this is all stuff I'm doing on my personal laptop with Community Edition of LabVIEW. So it requires no licensing or anything that work has provided. And they're very happy that I'm spending a lot of my personal time getting something that works better. So yeah, there's only a couple minutes left. Feel free to hit me up on the networking tab or send me a message through the Ring Central. Oh, QA. Oh, QA tab. So does it work across different networks? Also, does multicast function properly over a VPN connection? So that entirely depends on all of the configuration. Um, Multicast can work over VPN. Uh, and I'm not sure exactly what you mean across different networks. A lot of the configuration does have you bind to a specific network interface. If you needed to do an application that split two networks, you would write your application to spin up two TCP messaging instances, and you would need to implement a little bit of glue layering. Um, but if you mean something different than that, definitely clarify that, please. And then, yeah, I'll be. We're just starting to use Volatus at work. I'm getting started using that on the next couple of test systems that are coming up. So I will be publishing a couple of update videos on YouTube when I get that done. And when you use that, you're exchanging all of this code complexity for configuration complexity. Um, but the module pattern is quite simple. It does just do the string and variant. All the stuff that Dan and Casey said were reasons why Actor Framework is good, and I agree. I actually initially wrote Volatus as an Actor Framework based application framework. Well, Actor Framework is the module framework, and Volatus was the application. Did I just say the same thing again twice? Actor Framework is the module framework. Volatus was the application framework. Um, so Volatus would be opinionated about debug logging and event collection and how data moves around the application. What common components get shared throughout the application, how the remote messaging interfaces with the module messaging. Um, but that was starting to get really bloated. So about 2 weeks ago, I started over and started it again with just a basic QMH pattern, which is going to be much more approachable for my current peers that will be um, developing in it. QA tab has a dot again. I mean, the question was how compatible is the Protobuf library? It doesn't handle one of, and it doesn't do imports yet. Those are the two things I know of that it doesn't handle properly. Doing imports. Oh wait, no, I lied. It does do imports. Um, it doesn't do include paths for the import. So if you're not specifying importing a file in the same folder or a relative path relative to the starting file, it won't know how to find that yet. The normal protobuf tooling, the Google provided Proto C, has a command line directive for specifying include paths. Um, it's missing that, and it's missing one of. Other than that, it's got everything. All right, well that's time. So this is probably getting shut off.